C option is not correct, right?
C option, distance between local maximum and minimum, you have found it. Okay, maybe you have found it. Yeah, C option is not correct.
Yeah.
That is easily found, can be found by taking derivatives.
N minus 3.
So that's fine. B option, how will you check? See, we have intermediate value theorem, right?
Yeah.
So if you have two values of the function which are negative and positive, then there is one root between them, right? So just check f of minus 2, what comes? F of minus 2 would be minus 8 plus 6 plus 1. So minus 1, right? And f of minus 1 is minus 1 plus 3 plus 1. So it is positive, right?
Yeah.
So there is a root between these two.
Yeah.
Yeah.
So you can just check by checking the values here. So you will, if they have equal and opposite value, not equal and opposite signs, right?
Yeah.
Then there is a root in that interval, right?
Yeah.
So just by that we can confirm B option. So it turns out that B is right. So there is a root in this, there is a root in this, there is a root in this.
Okay, so with that we can say D is also correct.
With that we can find out GIF,
Yeah.
right?
Yeah.
So minus 2, 0 and 1. So minus 1, right?
Yeah.
So intermediate value theorem is very useful in finding at least the region in which the roots lie, right?
Yeah.
Okay. Fine. Okay, tell me your limits doubts. What are the doubts? We'll do that first. We'll then do the problems.
Yeah, so I'll just send you the book.
Rishi, you have solved your limits book.
I've started doing.
They have not started doing that, right, in class?
We
They
started yesterday.
Yeah. Yesterday.
We had a 2-hour class.
Okay.
Yeah. So do you get the book?
Yeah, one second.
Yeah.
Okay. Tell me which one.
So I have a doubt in the third beginner box. The first question.
Okay. Limit of x tends to infinity.
Yeah, that one.
X tends to infinity. X ln x plus a minus ln x. Ln x plus a minus ln x. Okay. So right now x tends to infinity is there. So why not write it like this? Limit x tends to infinity x. This is 1 ln x plus a by x, right? So limit x tends to infinity ln, it is 1 plus a by x power x, right?
Yeah. Oh, right.
This part, I know what this part tends to. This is fitting my pattern, right? E power a, right?
Yeah, it's taking the thing
So,
x on the top. Yeah.
So ln e power a will be a. This is tending to 0, this is tending to infinity. That is the pattern.
Yeah.
Okay.
Got it.
Next one.
Next one is in exercise 2.
Okay.
The second comprehension.
Exercise 2, second comprehension. Circular arc, that one. Huh? Circular arc of radius 1 subtends an angle of x radians as shown. The area of the circle center of the circle is O. C is the point of intersection of two tangent lines at A and B. Okay. Tx be the area of the triangle ABC. Sx be the area of the shaded region. Okay, so you just have to find areas, expressions for the areas. C is the intersection of two tangent lines at A and B. So A and, okay, fine. So there is an arc like this. This is B, this is A. There is an R. This is angle X. And A and B have been joined. So this is a chord. And then there is a tangent here and a tangent here, which intersect at C. Right?
Yeah.
Okay. So now you have triangle ABC. Okay. So question says that T radius is 1. So this is 1, this is 1. And Tx is the area of triangle ABC. T of x, area of triangle ABC. And this angle is x, right? So, okay. So this is the tangent line. So this angle is 90 and this angle is 90, right? So these angles are 90 and 90, right?
Mm.
Correct? Correct, no?
Yeah, yeah.
So this point OABC is a cyclic quadrilateral. Cyclic because opposite angles are supplementary,
Yeah.
right? Aditya, you are understanding, right?
Yes, sir.
So this is cyclic, so this angle we know now, pi minus x, right?
Right.
And this side also we know, this side, by cosine rule or sine rule, whatever you want, right? AB side length we know. AB side length we know. Length of tangent also you can figure out, right? Length of tangent will come by doing power of a point, right?
Yeah.
Like you can say that power of point C will be OC square minus OB square, right? Or basically Pythagoras theorem, right?
Yeah.
So 1 second. Can we find this side BC? Length of tangent can we find here easily? That is the only thing you need to find. Because then you will be able to write Tx, right? You should be able to find it. This is a circle. This is a situation like this. Like this. Actually, better drawing would be like this. Right? We have done this before in circles and all, if you remember.
Right.
O, C, this is joined, this is A and B, right? We just have to find out our AB, right? That's obvious. R, okay, we know this triangle and this triangle congruent. So this is x by 2, right? And this is x by 2, right? Now it is obvious, R is 1. Now you can just say this is 90 minus x, or pi by 2 minus x by 2. You can just take ratios in this one, right? You can say tan of x by 2 will be this by this, right? Tan x by 2 will be CA by OA, right?
Yeah.
So CA is by 1. CA is tan x by 2. Right?
Correct.
Yeah.
So now area of triangle ABC, area is half BC sine this angle, right? So half this into this. Both tangents will be equal length. So half into tan x by 2 whole square and sine of pi minus x, right? So sine x. So it is sine x into tan square x by 2 by 2. This is your T of x, right? Now limit is obvious. Limit of T of x by x cube is obvious, right? X tends to 0, T of x by x cube. Let's find the answer. Sine x by x collect like this. Tan square x by 2 by x square. So 2x square is there. So I'll divide by 4 and multiply by 4, right? So 1 by 8 is the answer.
Yeah.
So that is that. And now it is obvious you can find S of x, no? S of x is the shaded area. So just subtract the sector area and triangle area. It's obvious stuff. You can do the rest, right?
Yeah.
S of x you'll be able to find. Then limits are easy actually. You just have to figure out the diagram. That's all. And the diagram is actually better drawn like this. We have done this when we did circles, right? We found everything we found here. Everything that you need, you can find. This triangle is congruent to this triangle.
Yeah.
Right?
Yeah.
Right.
Okay. What is the next one? So you have to remember your circle stuff. You cannot forget it. Then
Next one in exercise 3, I have a doubt in third and fourth one.
exercise 3, third and fourth one. Okay. Value of this limit. Limit of n tends to infinity. N tends to infinity. 1 by root n square plus 1 by root n square plus 1, so on till 2n. N square plus 1 plus n square plus 2n, right? That is what it is, yeah. N square plus 1, n square plus 2, and so on till n square plus 2n. Okay. Limit n tends to infinity is there. And so divide everything by n square. Take n square outside basically. So it is becoming root of 1 plus 0, right? Plus 1 by n, 1 plus 1 by n, right?
Yeah.
No, 1 by n square, right? N square, you'll take out, then it will be this, right? The next term will be n, 1 plus 2 by n square, right? Correct?
Right.
Yeah.
So on till the next last term will be 1 plus 2n by n square, right? Okay. Okay. Fine. This is what is coming, no?
Yeah.
Limit n tends to infinity. Take the 1 by n outside. So this starts looking like this. Limit n tends to infinity. 1 by n. 1 plus 0 square by n square plus 1 by 1 plus 1 square by n square. Wait.
Yeah.
Once. Okay. This fine. Root over 1 plus root. This is slightly annoying now. It is root 2 square times. That is weird. N square is there. Should if I take n common, what will I get? If I had taken just n common, I would have gotten n here.
Yeah.
Root n would have come outside and n would have been here. And here would have been n plus 1 by n, and n plus 2 by n, and n plus 2n by n. Right? Okay.
Yeah.
1 second. Yeah, I'll just write it like this only. Root 2 squared by n square, and so on, plus 1 plus root 2n squared by n squared. Right now, this is the situation. Next, the next term here would have been root 3 squared by n squared, right? Because it would have been 3 by n squared, right?
Correct.
Yeah.
Okay. Okay, fine. So we can write this inside part as a summation of r goes from 0 to 2n. Okay. And it is looking like 1 by root over 1 plus root r square by, there is a slight problem by n square. R by n, I want to write it as r by n. Hmm. R by n again. Fine. N square plus 1. Hmm. Okay. Let me just look at the question once. N tends to infinity. This is n square plus 1, n square plus 2. Till root of n square plus 2n. Okay. The reason I'm trying to write it as f of r by n is because 1 by n summation, let's say r goes from somewhere to somewhere. If you have this limit n tends to infinity 1 by n, summation r goes from some point to some point, and there is a function of r by n, right? So then that can be written as a definite integral of f of x dx, where x goes from x is your r by n, and 1 by n is your dx, and f goes from whatever limits r values go from r is equal to a, so x will be a by n, x will be a by n to b by n. So actually when we study definite integrals, then this part will be clear, like an integral is just the area, right? So
Yeah.
so if you have if you have a function like this and you are taking function values here and in this tiny dx, right? Suppose this fx dx, you are taking area of this, right? Fx into dx will be area, right?
Yeah.
And you are varying your x from some point to some point, right? And that gives you total area under the curve, right? So
Correct.
here your r by n behaves as your x, and if you go forward, the values of, because your total range you are dividing into small portions, and 1 by n behaves as your dx, tiny displacement. So that is a standard technique, but right now it feels like the question is not fitting that pattern. 1 second. It looks like we will study that in more detail later. So right now I was thinking maybe it is that, but it seems like something else. N square plus 2 plus root over n square plus 3 plus this root over n square plus 2n. Okay. Uh, 1 plus 1 by n, 1 by n square, 2 by n square, 3 by n square, 2n by n square. Okay. So general term here is what? Root over n square plus r, right? This is my general term. Summation r goes from 0 to 2n.
Yeah.
This is the thing. This is what you have to sum, and then take limit n tends to infinity.
We can't
Right.
multiply and divide the like root of n.
Maybe we
Star
can.
or something.
Maybe we can. 1 second. If we try to do that rationalizing, if you multiply by root by n square minus r, what comes? N square minus r on top, and root n square minus r will become basically, no, not n square minus r. I think we have to do n square plus r, right? So
Yeah.
it will become root over n square plus r by n square plus r. Okay. and summation over R. Don't think that helps anyone. Okay, so why don't we this sum feels like see the terms are becoming smaller and smaller, no? This is the largest term here. Everything is smaller, so it will be some finite value. I mean, every term tends to 0, but there are many of them, right?
Yeah.
So, okay. This is 1 by n, 1 plus r by n squared. Summation r goes from 0 to 2n. So that is basically summation of r goes from 0 to 2n. 1 by n root over 1 plus r by n into 1 by n. R by n into 1 by n. Okay. I'm just going to try something and see what is coming. 1 plus 1 by x integral. Can we do this integral? If it was 1 plus 1 by so this is straightforward, right? It is 1 plus x to the power minus half integral, right?
Yeah.
So integral of this is 1 plus x to the power half and 2. And limits will be when r goes 0, it is lower limit is 0. R by n 0 to 2. Let's check what is coming. 2 into 3 root 3 minus 2 into 2, right?
Oh yeah, 2, correct.
Check the answer once.
But answer should be I think it should be an integer. Answer is given 2.
Answer is 2.
Yeah.
Okay, so then I will check 1 by root over 1 plus x squared. And in that case, your integral becomes log of x plus root over 1 plus x squared. This is a standard integral. You don't have to worry about it right now. And 0 to 2 becomes log 2 plus root 5. Okay, this is not coming the same. Fine. Answer is given 2. Huh? Okay. This is not going to give 2 for sure. This is giving something like this. Okay, then maybe this is not the thing. This is integral version is not working. So, okay. So it can be done by normal limit methods then. How? I have seen this before. It's like I've forgotten how to do it. 1 second. Solution. 1 plus 2 by n squared. 2 by n squared. The thing is that there is no way to do logs or anything. That is the whole problem. 1 plus 1 by n. Oh. Oh, wait. We can do binomial theorem, no, at least.
Right.
We can do Taylor series and all, no, something.
Yeah. For negative index, we can use it. Or we can do it this way also.
Yeah. Now it will be done, I think. So you can say 1 plus r by n square to the power minus half, right? Divided by n.
Yeah.
Okay, great. So, and this is summation also is there, right? R goes from 0 to 2n, right?
Yeah.
So first I will simplify this part and then I will think about the summation. So, okay. Now I think it will be doable. 1 minus r by 2n squared, right? First term, right?
Yeah.
Plus minus half minus 1 by 2 into r square by 2 n power 4, right? Correct? And the next term I will not write because it will become too many powers. Right? There is an
Yeah.
n also here. So it is coming 1 by n minus r by 2n cube. And this term is becoming plus. This is half into half plus 1. So 3 by 2. So 3 by 4. So 3 by 8. No, 3 by 4 is coming here. And there is a 4 here. So 3 by 16, right? R square by n power 5, right?
Right.
Correct?
Yeah.
Some higher order terms, right? And I have to do the summation over R goes from 0 to 2n, right? Great. Okay, so now it is done, I think. That is what you have to do. So now let's try to think of the summation. Okay, one second. There are basically 2n plus 1 terms, right?
Yeah.
Yeah.
R goes from 0 to 2n means 2n plus 1 terms. So 2n plus 1 by n minus, now you have to sum this. So 1 by 2n cube summation r will be, there are, r goes from 0 to, okay, so 1 to 2n summation, right, basically, right? So that will be 2n into 2n plus 1 by 2, right?
Correct. Correct.
Correct.
Plus 3 by 16, r goes from 1 to 2n, n power 5, r square summation 1 to 2n, right? So 2n and 4n plus 1, 2n n plus 1, no, n plus 1, 2n plus 1 by 6 is a formula. So 4n plus 1 by 6, right?
Correct.
So notice that every term has a 1 by n. This is quadratic.
Yeah.
Every term, no term can exceed, like this is always going to be some square, right?
Correct.
And this limit is 2 plus 1 by n, right?
Yeah.
Everything disappears when you take n tends to infinity, answer is 2.
Understand.
Okay, so basically there was no other way, nothing you could have done. It's just binomial theorem. So write a general term, write your binomial theorem for negative index, and then you will begin to see what is happening. It is
Correct.
like this. And then just check whether every term is disappearing or not. You do the first 2 terms, you will understand that every other term will have 1 by n, 1 by n square, and so on. So the answer is 2.
Right. Got it. Got it.
Okay. Question 4 is value of the limit x tends to 0, limit x tends to 0, n sin x by x GIF plus limit x tends to 0 n tan x by x. Limit x tends to 0 n tan x by x GIF, where it is greatest integer function. The value of the limit is L of n, then L of 5 is what? He's saying that this is some function of n, and you're being asked to find L of 5. Okay, when n is equal to 5, right? Okay, so the question is actually limit x tends to 0, 5 sin x by x.
Yeah.
Plus limit x tends to 0, 5 tan x by x. Okay. Okay. Fine. So I mean, this seems very straightforward now, right? Because we know sine x by x tends to 1, but from the 0.99 side, right? And tan x by x tends to 1, but from 1.01 side, right? So 5 times this will be 4.9 something. So this will be 4. And this will be 5.1 something. So 5. So answer should be 9, right?
Yeah.
Right.
Check the answer. Should be 9. It is, no?
Yeah.
Okay. So that is, you just need to know which side it tends to 1 from, right? We have done that.
Yeah.
So that's all. Okay. Next one is what?
From 4B. I have a doubt in the first question.
4B. Wait 1 second. Okay, 4B is ahead of it. One second. 4A. After that 4A, there is 5, it seems. But there is 4B also. Oh yeah, there is 4B. First
Yeah.
question.
Yeah.
Positive increasing function. Okay. Question 1. F of R to R is a positive increasing function. F of R to R is positive increasing function. So we know that it is f dash x is greater than 0, right? With limit x tends to infinity, f of 3x by f of x. F of 3x by f of x is equal to 1. You just have to do L'Hopital rule. There's nothing here.
Oh.
Why? Because if it is positive increasing, when x tends to infinity, this should tend to infinity, right?
Yeah.
It is always increasing, no? So
Yeah.
it will tend to infinity, this will tend to infinity. It is infinity by infinity form, right?
Yeah.
So you get f dash 3x into 3 by f dash x, right? Now what is saying is this limit is equal to 1, right?
Yeah.
Yeah.
Okay, wait 1 second. So limit x tends to infinity of this part is equal to 1. Okay. Positive increasing function is f of 3x by this is 1. Okay. So f dash infinity. Okay. F dash doesn't have to be infinity, no? F dash will be some positive value.
Yeah.
But if it's a function of, if it comes out to be a function of x, then it will tend to infinity, right? Let's say if it was x cubed and we get 3x squared, then limit x tends to infinity would still be infinity.
1 second. What we know here is f dash x is greater than 0. Positive increasing function. So it goes up to infinity. So infinity by infinity form. So that is finite. So, oh, okay. That is finite. So both of them are tending to infinity. So 3 f dash 3x by f dash x is tending to 1. Here you are asking for limit x tends to infinity 2 f dash 2x by f dash x, right? Oh, okay. So you know here that f dash infinity by f dash infinity into 3 tends to 1, right?
Yeah.
So here what is being asked? 2 into f dash infinity by f dash infinity. Right?
2 by 3, got it.
So this tends to 1 by 3. So this tends to 2 by 3.
Right, got it.
By the L'Hopital logic only, there's nothing here. See, anything that is an AIEEE question or a JEE mains question cannot be hard.
Mm-hmm.
AIEEE used to be the earlier JEE mains. It cannot be hard, so it must be some obvious thing.
Hmm.
So go ahead.
Fifth.
So, sir, limit of f of 2x by f of x is 2 by 3.
Yeah.
Because you differentiate it, it will be 2 f dash 2x by f of x, right?
Yeah.
So when you put infinity, it becomes the ratio of f dash infinity by f dash infinity, right? Something like that.
Mm-hmm.
F dash 2 infinity by f dash infinity, right?
Yeah.
It is similar ratio here also. That is equal to 1 by 3. No, this must have been 1 by 3 to be giving answer 1, right?
Yeah.
Yeah.
So 1 by 3 here and 2 here.
Suppose we use like the sandwich theorem for this question.
Sandwich theorem.
If it's increasing, meaning f of x is less than f of 2x is less than f of 3x, right?
Correct.
And then if you divide by f of x.
Okay, you are saying f of x is less than f of 2x is less than f of 3x.
Yeah, and now you divide.
1 is less than f of 2x by f of x of 3x by f of x. But the problem is that
limit, right?
Oh, okay.
What?
Limit x tends to infinity. This is
then
tending
the
to 1.
Equal to will go.
Oh, answer should be 1 actually.
1, right?
What is the answer once? 1 it should be.
I'll check it.
It will be 1. I'm sure I'm wrong and you are right here. Yeah. It is 1, no?
Yeah.
So here there is a slight problem. Obviously, this is not mathematically sound what I have done here because you're comparing 3 into infinity and 2 into infinity and it doesn't seem right.
Right.
You understand? What he has said is correct. That is the better way to do it. That is correct. There is no doubt about that, right?
Yeah.
This sandwich theorem is working. No, it is a positive increasing function. You divide by f of x, you get this thing, and this limit has been given as 1.
Yeah.
So both sides, the functions are equal to 1. So middle one has to be 1. Correct. Yeah. Makes sense.
Yeah.
So it is 1. The middle one is 1. Correct.
Yeah.
Which one is next one?
5 and 6.
5 and 6. 5 is the function is given. Okay. Fx is given to be 3x power 10 minus 7x power 8. 3x power 10 minus 7x power 8 plus 5x power 6 plus 5x power 6 minus 21x power cube plus 3x square minus 7 plus 3x square minus 7. Okay. You have to find limit alpha tends to 0. Limit alpha tends to 0. F of 1 minus alpha minus f of 1 by alpha cube plus 3 alpha by alpha cube plus 3 alpha. Okay. Is what? Fine. So I feel like x is equal to 1 should be a root of this. Let's check once. 3, 7 is 7, minus 4 plus 5 plus 1 minus 21. Minus 20, no, it doesn't work. Okay. Fine. Alpha plus 3 is minus 3 a root of, wait 1 second. Minus 3.
That'll be 2.
Okay. Okay, sum of either minus 3 or 3 has to be a root here. Let's just check once. So let's check minus 3. So it is 3 power 11, right? Minus 7 into 3 power 8 plus 5 into 3 power 6 minus 21 into minus 3 power 3. So that is minus of 3 power 3. plus 3 into 3 square minus 7, right? So this becomes, this is 3 power 3 minus 7 into 3 power 8, right?
Correct.
Plus 5 into 3 power 6 plus 21 into 3 power 3 plus 3 in 3 power 3 minus 7, right? So this is 22 into 3 power 3, and this is 5 into 3 power 6, and this is 3 power 3 is 27 minus 20 into 3 power 8, right?
Correct.
Minus 7.
Will be
Okay,
plus.
this is too large, right?
Won't that be plus? Yeah.
Plus. It is too large.
Definitely.
So we need, if you do 3 without doing minus, then what happens? It is,
might come.
this is the same, this part is the same. What is changing? This part is becoming plus, right? That's the only thing that changes, right?
That won't make such a huge difference because of 3 to the power 8.
Okay. So this part is same, 20 into 3 power 8, 5 into 3 power 6 is same. And this becomes minus 21 into 3 power 3. 3 power 3 plus 3 power 3, right? So it is basically minus 20 into 3 power 3. But that also won't work.
Yeah, because
okay, nothing is working. 7 works. Okay, let's not worry about it then. Then we have to basically figure out the limit here. Is minus 1 or 1 working? Minus 1 will not work. 3 minus 7 plus 5 plus 21. Plus 21 makes it too big.
Yeah.
Right? 3 minus 7 will be minus 4 plus 5 plus 1 plus 21. Okay. Okay, fine. Let's look at the limit right now. Let's see what is coming here at least. So you're getting 0 by 0 form, right?
Yeah.
So what I will do is L'Hopital, right? Limit alpha with respect to alpha. So f dash 1 minus alpha into minus 1 divided by 3 alpha square plus 3, right? This is what is coming, right?
Yeah.
So, okay. Now we have to, now clearly the denominator is no, okay, it's obvious. Clearly the denominator is 3, right? Because no longer 0 by 0.
Yeah.
You just have to find f dash this when alpha tends to 0, right?
Yeah.
So find f dash x and just put it.
Yeah.
Find f dash x, it will be 30 x power 9 minus 56 x power 7 plus 30 x power 5 minus 63 x square plus 6x, right?
Yeah.
And you have to put alpha f dash 1, right? So 30 minus 56 plus 30 minus 63 plus 6, right? So 60 plus 6, 66 minus 63 is plus 3. So minus 53 is coming.
Yeah.
So answer should be 53 by 3. Unless we have made some careless mistake. Hopefully not. Third one is the answer.
Yeah.
So it is L'Hospitals, okay? Directly L'Hospitals, nothing else. Don't try any factorization, just directly do this.
Yeah, I didn't. I was trying factorization, but yeah.
So where
Which
did
one?
the minus sign come from?
Minus sign as in where?
After
there was a minus 1 into
because f dash 1 minus alpha, f of 1 minus alpha, when you differentiate, it should be chain rule, no? Inside part also you have to differentiate.
minus 1 gets multiplied with that to make it positive.
Yeah.
So chain rule differentiation. Next one is which one? Sixth one.
Yeah, 6th one.
Okay. Value of limit. Okay, this feels like the 1 power infinity type of form. Limit x tends to 0, 1 by x.
Into 0.
Tan inverse x plus 1 by 2x plus 1. Okay, tan, okay, it is just L'Hopital again.
Oh, okay, then I'll do. I didn't.
So it is looking like 0 and there is a 0 there also, no?
Yeah, but then it's infinity into 0. Oh no,
Oh,
it's
no.
0
It's
by 0.
just 0 by 0 too.
Yeah.
This, write it like this and divide by x. This is what it is.
So,
You need to know how to differentiate it, that's all.
But
Differentiation of that is 1 by this whole square into differentiation of this part.
mm-hmm.
By quotient rule, differentiate this and divided by 1. That is the answer.
Oh, okay.
So you can do that. It's just L'Hospitals. See, most of the IEEE problems are just L'Hospitals.
Right, get it.
Next one.
Next one is 11.
Limit 1 minus, okay. Limit x tends to 0. 1 minus cos 2x whole square by, okay, 1 minus cos 2x whole square by 2x tan x minus x tan 2x.
I tried.
2x tan x. Don't do L'Hospital here.
I didn't do that. I tried to convert it into the known forms of tan x by x and like that.
So 1 minus this will be basically 2 sine square x, right?
Yeah.
It is 1 minus 2 sine square x, so it becomes 4 sine power 4 2x, right? No, not 2x. It's just sine power x, right?
Yeah.
By 2x tan x minus x tan 2x. Okay. So you need an x power 4 for this, right? So actually it is just becoming 4 sine 4x, okay, sine 4x by x cube multiplied by x cube here, and x comes from the factorization. 2 tan x minus tan 2x, right?
Yeah.
This is what is coming, right?
Yeah.
So
that,
this part is sorted. So
yeah.
you just have to find out this limit, right?
Yeah, that also we can split the thing and do it.
yeah.
How split the thing? What split?
Like we can bring x cube down, right, and divide, and then the 2 tan x by.
Best way would be doing series. Best way is series, fastest.
Yeah, series.
If you know the series of this tan x,
Yeah.
it is x plus x cube by 3, I think.
Yeah, x cube by 3
Plus 2 by 15 x power 5 and stuff.
Oh, x
So you
cube
can ignore those terms. So 2 tan x would be 2, 2, 4. And tan 2x would be 2x plus 2x cube. So 8x cube by 3, right?
Right.
Yeah.
So subtraction of this will cancel this term, but it will not cancel this term, right?
Yeah.
So it will be 2x by 3 minus 8x by 3. So that will become minus 2x cube, right?
Yeah.
So minus 2x cube limit will become just simple, right?
Mm-hmm.
It is minus 2 here, right?
Yeah.
So answer is minus 2.
Right.
Fastest is series. So you don't have to search for forms now. Like actually, once you have noticed this, like you need to know your basic 5-6 series, okay, Taylor series.
Yeah.
So use that when is needed. Then
20.
okay, 20 is okay. Limit of x tends to 1 minus root pi minus root 2 sine inverse x. X tends to 1 minus root pi minus root 2 sine inverse x by root 1 minus x. Root 1 minus x.
No, we have
Okay.
again.
First, you should convert it into the normal h tends to 0 form. You should put 1 minus h instead of x everywhere. 2 sine inverse 1 minus h, right? By
Yeah.
root over 1 minus h. That makes it h here. So limit h tends to 0, it becomes root pi minus root 2, just write it like this for now, and divided by root h, right?
Yeah.
So now it is 0 by 0, right?
Mm-hmm.
But maybe it is better to just do something else. Don't do 0 by 0. What I will do is I will multiply to rationalize the top part. Okay. So root
Okay.
pi plus root 2 sine inverse 1 minus h divided by the same thing, right?
Yeah.
So that makes the top part pi minus 2 sine inverse 1 minus h, right?
Yeah.
By root h and root pi plus root 2 sine inverse 1 minus h, right? And now it will be obvious because I will take the root h. This part, notice, is not tending to 0, right?
Yeah.
Right?
Yeah.
So I just have to solve the top, this part, right? So I will take 2 common. No. 2 common. So it will become pi by 2 minus sine inverse 1 minus h, right? Correct? So that is cos inverse 1 minus h.
Yeah.
So 2 cos inverse 1 minus h by root h I have now, right? And here there is root pi plus root 2 sine inverse 1 minus h, right?
Right.
Okay, so this limit I have to figure out. Cos inverse 1 minus h by root h. Okay. So can we write, we can write cos inverse 1 minus h in terms of sine inverse. So think about that. What is cos inverse 1 minus h? Basically,
1 minus.
so base is 1 minus h, hypotenuse is 1, right?
Yeah.
So sine inverse would be perpendicular by hypotenuse. So root over 1 minus h whole square by 1, right?
Yeah.
Correct?
Yeah.
So,
Yeah.
so this will be, notice it will be 1 plus 1 minus h, so 2 minus h multiplied by 1 minus 1, no, 1 plus 1 minus h is 2 minus h, 1 minus 1 is h, right?
Yeah.
Correct? So it is this thing, and 2 times of that, right? 2 times of this, right? 2 sine inverse this, right?
Yeah, we have.
So it can be written as one angle, double angle.
Yeah.
So this is 2 theta, right? Like this is 2 theta is an angle, right? So sine 2 theta would be just simply 2 sine theta cos theta, right?
Correct.
Yeah.
So 2 theta is sine inverse 2 sine theta cos theta, right? Right? So 2 theta angle that I wanted is just sine inverse 2 sine theta cos theta. 2 sine theta. Sine theta is what? This part. 2 minus h into h, and cos theta is 1 minus h, right?
Yeah.
Correct. So this thing has become sine inverse this, right?
Yeah.
Correct.
Yeah. Yeah.
And there is a root h also. So now notice that this part is tending to 1, this part 2 minus h is tending to 2, right? Correct.
Right.
So it is sine inverse something like 2 root 2 and root h, right?
Yeah.
Right?
No.
If you put the h tends to 0, so put a 2 root 2 here and a 2 root 2 here, and this is also root h, right?
Yeah. Yeah.
Sine inverse x by x limit tends to 1, right? So this part becomes 2 root 2, right?
Yeah.
And this part becomes root pi plus root pi, right? So 2 root pi. So you get root 2 by pi.
Right. Right.
Okay.
I mean, this may not be the fastest way. Maybe L'Hopital is faster. Like
Yeah.
you could possibly do L'Hopitals and get it faster, right?
Yeah.
That is also a possibility, but without L'Hopital also you can do it.
Yeah.
This is pi by 2 minus some angle that I converted to cos inverse. Then actually I should have done here only 2 cos inverse h. I should have written 2 times that angle, just what I did at the end here, right? I made it into one angle, right?
Yeah.
Yeah.
So it is sine inverse this and 2 sine inverse that, right? You have to make it into one angle, and I got it as sine inverse this, right? Once that became sine inverse on top, you have a root h in the denominator. So I have to figure out what happens when limit h tends to 0. you have root h as it is, but the other parts are becoming 2 root 2, right?
Yeah.
So it is 2 root 2 root h inside. So I need a 2 root 2 root h outside below. So I multiplied by 2 root 2, and then this limit tends to 1, I know. So after that, it is over.
Right,
So,
right.
but this is basically not going to be the fastest way. Best way would have been L orbital, I think. This one.
I didn't know the derivative. So.
Derivative, but you need to know, okay?
Yeah, but we can calculate it by taking it is equal to y, but
Yeah. You need to know sine inverse x, cos inverse x, tan inverse x derivatives.
yeah, I'll
D by dx of this is 1 by root over 1 minus x squared. For cos inverse x, d by dx is minus 1 by root over 1 minus x squared, I think. And tan inverse x is 1 by 1 plus x. So these you need to know. What is the next one?
I'm done with my doubts. I've only solved, like I solved till unit express, but after this I don't have any doubts.
Okay, so try solving everything. Eventually, you have to solve everything.
Yeah,
Do the review exercise also.
I mean that. I just started it today morning, so I'll finish it by tomorrow or day after.
Okay.
That's exactly 3 questions.
Okay. The next one for us is 1 second. Okay, this is the question. Let f of x.
Sir,
F
I've
of
sent
x.
3 questions
Oh, okay. Where have you sent?
on the group.
Okay. Limit n tends to infinity, this one. Limit n tends to infinity. N sine 2 pi root over 1 plus n square. Okay. N is a natural number. Okay. So n tends to infinity. So first thing to do is write it like this, right? Okay. Write it like this, where this is now tending to 0. And the problem is that this part is tending to infinite. Okay. That is weird. Because then sine doesn't have a limit when argument becomes infinite. Okay. 2 pi root over 1 plus n square. Fine. It might not exist limit here. I have a doubt that it will not exist. But we can check it once by doing the expansion for sine, right? Sine x is what? X minus x cubed by 3 plus x power 5 by 5, right? No, 5 factorial. Right?
Yeah.
This is the expansion of sine. So sine of this thing will be n tends to infinity. It's totally weird. It's 2 pi root.
We can also divide by 2 pi root 1 plus n square and multiply with it, right?
You can, but does it help?
I mean,
2 pi root over.
we're getting
The problem is this is tending to infinity. There is no limit for sine x if x tends to infinity.
right, sorry, correct.
No limit.
Right.
Because it oscillates very violently, right? So I'm just checking. I feel like there is no answer to this. There is no limit to this.
It's pi.
Answer is given.
Yeah.
Huh?
It's pi.
Okay, that is weird. Okay, 1 second. Let me look at the question again. N sine 2 pi n tends to infinity. Okay, maybe we'll check what is happening in Taylor series. Let's see. 2 pi root over 1 plus n square whole cube by 3 factorial. I'll ignore the other terms. And you have a n outside, right? N outside. So limit n tends to infinity. Okay. Uh,
Like, is n being a natural number going to help us in any way? Because we don't usually keep like.
if n is a natural number, n square plus 1 basically is not factorizable, right? So root of n square plus 1 will be some root something, right? So 2 pi into some root something. So basically it is ensuring that it is not 0, right? Sine of that will never be 0, right? Sine is 0 only on the integer multiples of 2 pi, right?
Correct. Oh, okay, right.
Of pi. So it is ensuring that this thing is never 0.
Yeah.
But the problem is that there is an n here, right? So this thing is never 0, so it is between -1 to 1, right?
Yeah.
The sine thing. So the answer will be between -n to n, it is coming. But how will you find the limit? It is tending to infinity. -1 to 1, but never 0. So I don't think there should be a limit to this. Like, if it was something 0, then maybe you can think it will be finite, right? You understand? Something tending to 0 into something tending to infinity, there is a possibility that it is finite, right? But something between -1 to 1 multiplied by infinity, which is never 0, I doubt that it can be finite. Or it can be any particular value. How will you figure out what particular value it is? Okay, let's do one thing. 1 second. Let's do one thing where we do binomial theorem on root 1 plus n square. Sine 2 pi root 1 plus n square. So 1 plus n square to the power half is what? 1 plus half into n square plus half minus half by 2 n power 4 and so on, right? So it is 1 plus half into n square. Actually, the problem is that n is very large. No, we cannot do it like this. We have to do it like divide by n square outside, take n square outside. So it becomes 2 pi n, 1 plus 1 by n square, right? And now you can do binomial theorem here because x is small now, right?
Yeah.
So 1 plus 1 by 2n square plus half into minus half. So minus 1 by 4 into 2, 1 by n power 4, right? So we are getting 1 plus 1 by 2n square minus 1 by 8n power 4 and so on multiplied by 2 pi n, right?
Yeah.
So that becomes 2 pi n plus 2 pi by n, pi by 2n, right? No, pi by n, correct? Pi by n, right? Minus 2 pi, 2 cancels, so pi by 4 n cube, right? Correct? You have to find sine of the, oh nice. Oh, it is coming. See? Sine of integer multiple, you can ignore this.
Yeah.
So it is just sine of pi by n minus pi by 4n cube, right? Great. Divided by 1 by n.
1 by n.
Multiply by pi, multiply by pi, right?
Right.
It is pi by n.
Yeah.
Tending to 0, tending to 0. Right?
Yeah.
Ignore this. This tends to 1.
Yeah.
This is just wonderful. Okay. Basically, what happened? We expanded root over 1 plus n square properly. Notice that directly you cannot expand it by binomial theorem. Remember? Like you have to make 1 plus x should be much smaller than 1. Then you can do this part properly. You should ignore these terms because n is very large, right?
Yeah.
So only first 2 terms you can take, right? So when you take first 2 terms, it becomes 2 pi n plus pi by n, and you can ignore these, right?
Yeah.
So sine of some 2 pi n plus pi by n will be just simply sine pi by n. So now you have to do limit of n into sine pi by n, right? So that is 1 by n and pi. Answer is pi. Right?
Yeah.
Okay. Then the next one is limit 4 to n tends to infinity. N tends to infinity. 4 power n plus, what is it? Z power n.
No, it's 7.
Oh, 7 power n. 2 power 1 by n. This is easy. Just divide by 7 power n.
Yeah.
So 7 goes outside. It is 1 plus 4 by 7 power n to the power 1 by n. And this part limit will be e power 4 by 7.
Yeah.
The answer is this.
Right. But dividing by 4 power n won't help.
Because then it is becoming greater than 1. That doesn't tend to 0, no?
Yeah.
Correct.
You have to make it fit the pattern, something tending to 0, something tending to infinity.
Yeah.
So therefore, dividing by 7 power n is the right step. This is the answer. Then the next one is cos square, this thing. Limit of, 1 second, n tends to infinity. Cos square of, is it a GIF? No.
No.
N cube plus 2n square plus 5. N cube plus 2n square plus 5.
Cube root of that.
Cube root of that. Cube root of that into pi.
Yeah.
Okay, similar to the previous one.
Yeah. Something 90.
So something like that you have to think of. Okay, so cos square of some angle, right? So okay, this part we have to figure out a little bit. N cube plus 2n square plus 5. So okay. Okay, so n cube plus 2n square plus 5 to the power 1 by 3 we have to figure out. 1 by 3. So since n is turning to large thing, the idea is let's divide by n first, right? The n cube, let's divide by n cube, take n outside. Okay, so n outside, you have 1 plus 2 by n plus 5 by n cube, right? Correct?
Correct.
And now I will obviously ignore 5 by n cube compared to this, right?
Yeah, so it becomes n pi.
Because n is n into infinity. And now
Yeah.
just do 1 plus 2 by n power 1 by 3, right? By binomial theorem, we can do this. 1 plus 1 by 3 into 2 by n plus higher order terms, right? Which I will again ignore eventually, right?
Won't it
So,
be directly 1 to the power because then sending to infinity.
so this will become, what are you saying?
Won't it directly be 1 to the power 1 by 3 because n is either way tending to infinity, so we can ignore it because that is easier.
And no, I mean, it is not tending to infinity, dude. We can say that it is n plus 2 by 3, no? Plus other terms having 1 by n and all. Tends to 2 by 3.
Right.
You cannot directly ignore anything. You understand?
Yeah.
It is important to take the first term or at least second term and check what comes. If you take directly, na, everything will be wrong.
Right, got my mistake.
It is tending to 2 by 3, this whole thing, right? This
Yeah.
whole thing tends to 2 by 3 as n tends to infinity. Okay. So answer will be just 2 pi by 3 cos square, right? 1 by 4. Right? How did we do it? We took n outside, then thought about this. We expanded it by binomial theorem, got one term. Other term will have 1 by n square. So it will not matter. So what will matter is n plus 2 by 3 Wait, what? N plus 2 by 3. That should matter. 1 second. N pi plus 2 by 3 is coming my angle, no? But n pi plus 2 by 3 and you do cos square and all, it gets properly cos square 2 pi by 3, right? Right? There is no issue. Cos n pi plus 2 pi by 3. That is the real thing, right? So that becomes cos square 2 pi by 3 only.
But then, yeah, in fact doesn't matter. Yeah.
If it was something else, it might have mattered. If it was cos of n pi plus 2 pi by 3, it would have mattered.
Right.
Because then it would have been negative, right?
Yeah.
Okay. Nothing else, huh? No other doubts?
Yeah. I don't have any.
Okay. So then we'll stop at this point. Friday and Saturday we'll do a physics class. Okay. So do the capacitor exercise in physics and come.
Yeah.
Capacitor
Will we
HCV
discuss-
exercise. Yeah. We'll be finishing capacitors by Saturday. So make sure that you do the exercise. We'll discuss all the questions. We'll do some extra questions now.
Right.
Okay. That's all then. Bye.
Nice.
Hmm.